All right, let's jump right in. For decades, we've had this core belief about how reality works. The idea is that if you zoom out far enough, the universe is pretty much the same everywhere. It's uniform. But what if that's just not true? What if there are things out there so unbelievably huge that, according to our own rules, they just shouldn't be there? And that's really the big question we're getting into. A bunch of recent discoveries have found things that seem to completely ignore a sort of cosmic speed limit, and it's making us ask a pretty fundamental question. Is there a maximum size for anything in our universe? So, to get why this is such a huge deal, we've got to zoom out. I mean, way, way out. Past the planets, past the stars, even past our own galaxy, so we can see the real blueprint of the cosmos.
Okay, we all know what galaxies are, right? These amazing islands of stars. And our little pocket of the universe is just packed with them, something like 2 trillion in total. But the real mind-bender isn't the galaxies themselves, it's how they're all arranged.
See, it turns out they're not just sprinkled around at random like someone spilled some glitter. Nope, they actually clump together in these gigantic superclusters. And these superclusters are all linked up by these even bigger bridges of gas and, that invisible stuff, dark matter, forming these long, almost delicate-looking threads.
And when you put it all together, what you get is the largest known pattern in all of existence, the cosmic web. It's like the skeleton of the universe, a beautiful, crazy, intricate network with these huge empty spaces or voids in between the threads. For the longest time, we thought, this is it. This is the biggest thing there is. Now, for this whole cosmic web thing to work the way we think it does, it has to play by a very specific rule. I'm talking about a foundational idea that pretty much all of modern cosmology is built on. It's called the cosmological principle. And the idea is actually pretty simple. If you could zoom out far enough, all those clumps and voids of the cosmic web would just blur together. It would look like a smooth, uniform haze. The best analogy? It's like the static on an old TV screen. Just random noise, no big patterns anywhere. And, this isn't just some fuzzy concept. There's a hard number attached to it. Our models of the Big Bang are pretty clear. There just hasn't been enough time since the start of everything for gravity to pull together a single connected structure bigger than 1.2 billion light-years across. Think of it like a cosmic speed limit for construction. Go any bigger and you're breaking one of the most fundamental rules in the book. And this is where things get really interesting. Because astronomers started finding things that just blatantly ignore that 1.2 billion light-year rule. It all kicked off with an astronomer named Alexia Lopez. In 2021, her team was mapping out distant quasars when they stumbled on something that just shouldn't be there, a gigantic arc of galaxies. Then, in 2024, they found another one, another impossible object. And what is absolutely wild is that these two things are basically cosmic neighbors. They're in the same patch of the sky and at the same distance from us. So, just how big are we talking? Well, the first one, the giant arc, is a staggering 3.3 billion light-years long. That's nearly 3 times the theoretical limit. The second one, the big ring, has a diameter of 1.3 billion light-years, so it's just barely over the line, but it still breaks the rule. Now, finding one of these is a huge anomaly, but finding 2, right next to each other, that starts to feel less like an accident and more like a clue. As you can imagine, this has kicked off a major scientific debate. I mean, are these structures actually real, gravitationally connected things that force us to rewrite cosmology? Or are they something else entirely? The whole thing really boils down to 2 competing ideas. On one hand, you have the new cosmology camp. They're saying, yep, these things are real, and it means our standard model of the universe is missing something big. But on the other hand, you've got the cosmic phantom idea. This is the theory that they're basically just illusions, like seeing shapes in the clouds. Our brains are wired to find patterns. And to be fair, powerful computer simulations have shown that you can get these phantom structures just from random noise. The person who discovered them, Alexia Lopez, she's leaning towards the first idea. The way she puts it, finding 2 huge structures this close together by pure chance is, she calls it extraordinarily fascinating, which is basically scientists talk for, this is probably not a coincidence. But this whole thing isn't just about a couple of oversized galaxy clusters. No. This discovery is forcing us to rethink some of the biggest questions we have about the nature of reality itself.
I mean, if the cosmological principle isn't the solid law we thought it was, it opens up a whole can of worms. What does that mean for the actual shape of space? Or the true size of, well, everything? And maybe even for how it's all going to end?
Let's take the shape of space, for example. Our best measurements tell us the universe is flat. Now, usually when we hear flat, we think infinite, but that's not the only option. Picture a flat sheet of paper. You can roll it into a cylinder, right? So the left and right edges meet. Now, what if you could somehow connect the top and bottom of that cylinder too? You'd get a donut shape, a torus. That space is still perfectly flat at every single point, but it's finite. In a universe shaped like that, you could get in a spaceship, fly in a perfectly straight line, and eventually end up right back where you began.
And that gets us to the really wild difference between the observable universe, that's the 93 billion light-year bubble we can actually see, and the total universe. The theories about its real size are they're mind-bending. Some models suggest the whole thing is at least 250 times bigger than our little bubble. But the theory of cosmic inflation, it suggests it could be 10 to the power of 23 times bigger, a number so enormous it's basically infinite for all practical purposes.
But the rabbit hole doesn't stop with size. The fact that these giant structures even exist could be linked to the ultimate fate of the universe. New research is actually looking again at how long this whole show is going to last. And it all comes down to dark energy, that mysterious force that's making the universe expand faster and faster.
For years, the leading theory was a big freeze, where the universe just expands forever until it's cold and dark. But some new data suggests that dark energy might not be constant. It might be getting weaker. In this scenario, the universe's expansion could slow down, stop in about 11 billion years, and then reverse. Everything would come rushing back together, contracting like a snapped rubber band for 8 billion years, until, bam, a big crunch, collapsing all of reality back into a single infinitely dense point.
So we're left with this final massive question. Are the giant arc and the big ring just glitches in the matrix, statistical phantoms in an otherwise infinite and uniform cosmos? Or are they the first real cracks in the foundation of everything we thought we knew? The first hints of a universe that isn't just weirder and more structured than we ever dreamed, but maybe one that has a definite and possibly very dramatic end.